For as long as human beings have been around, they've explored from small steps to giant leaps. They've traveled and pushed boundaries ever further, from landing on the moon to landing on Mars, 480 million kilometers down the road. But what if you're not exploring for what is biggest, rather for what is smallest? If you want to travel to the smallest space, how do you do that? Well, welcome to Value Hunt, and this is an introduction to the semiconductor industry, its key players, trends and challenges. Well, what is a semiconductor first of all? A semiconductor is a type of material that has electrical conductivity between that of a conductor and an insulator. This means that it can conduct electricity but not as well as a metal, and can also act as an insulator, preventing the flow of electricity. Semiconductor materials are commonly used in electronics and are the foundation of modern electronic devices, such as transistors, diodes, and integrated circuits. Examples of semiconductor materials include silicon, germanium, and gallium arsenide. Basically, if you break open your phone and you watch with a microscope the chips in it, you'll see a bunch of zeros and ones, and that's the information that allows storing photos, for example. The chips on your phone are one of the many applications of semiconductor materials. With this being said, the semiconductor industry is a technology sector focused on the design, development, and production of integrated circuits, ICs, which are used in a wide range of electronic devices such as smartphones, computers, and automobiles. These chips are made from materials such as silicon and germanium, as I already said, and are capable of controlling and processing electrical signals. The industry has its roots in the early 20th century, when researchers began to study the properties of semiconducting materials. In 1947, the invention of the transistor by William Shockley, John Bardeen, and Walter Brattain at the Bell Labs marked a major breakthrough in this field. This development opened the door to the mass production of ICs, which rapidly transformed the electronics industry. The semiconductor industry experienced rapid growth during the 1960s and 1970s, with companies such as Intel and Fairchild Semiconductor emerging as key players. In the 1980s, the industry faced a major downturn, as oversupply and fierce competition led to falling prices and shrinking profits. However, the industry rebounded in the 1990s, with the rise of personal computers and growth of the internet driving demand for semiconductors. Today, the industry is a major contributor to global economic growth, with companies such as Intel, Samsung, and TSMC among the world's largest semiconductor producers. Now let's take a look at the explanation of the industry's key components, including design, manufacturing, and distribution. The design process is where engineers create blueprints for new chips, deciding what features and capabilities the chip will have. This includes the design of computer chips, memory chips, and sensors for cameras. The manufacturing process is where the chip is actually made, using specialized equipment to deposit thin layers of material onto a wafer of silicon. The distribution process involves getting chips to customers and assembling them into final products. This can include packaging, testing, and shipping the chips to the manufacturers who use them and create products like smartphones, computers, and other electronics. A great example of this last manufacturer is Apple. Apple uses chips, including processors, graphic chips, and memory chips, in various devices such as iPhones, iPads, and Macs. In iPhones, for example, the processors are responsible for handling many of the phone's functions, including running apps and managing data. Graphic chips are responsible for rendering high-quality images and videos, while memory chips store information and allow for smooth multitasking. Developing and manufacturing a whole iPhone involves a complex process that typically takes many months. The process starts with the design and development of the phone's hardware and software, which involves engineers, designers, and other specialists. The design must consider factors such as performance, power consumption, and user experience, and it must meet the requirements of Apple's quality standards. Once the design is finalized, the manufacturing process begins. Apple works with a network of suppliers and manufacturers primarily located in Asia, such as TSMC, to produce the various components of the iPhone, such as the display, battery, and cameras. These components are then shipped to a central location where they are assembled into the final product. During the assembly process, the components are connected and tested to ensure that they work together seamlessly. The phone is then loaded with the necessary software, including the operating system and any pre-installed apps. Finally, the finished product is packaged and shipped to retailers and customers around the world. Throughout the entire process, Apple is focused on quality and ensuring that every iPhone meets its high standards for performance and user experience. To sum up, Apple designs, assembles, and markets their products. That's why you see "Designed in California," not "Produced in California." Now here's an overview of the key players in the industry, including Intel, Samsung, TSMC, and more. Understanding ASML and its role in the industry is crucial in understanding the current and future landscape of the semiconductor industry. ASML is a Dutch company that specializes in the development and manufacturing of lithography systems, which are critical tools in the semiconductor manufacturing process. Lithography systems are used to print circuits patterns onto silicon wafers, which then go through a series of complex steps to create the final semiconductor device. ASML's lithography systems are considered to be some of the most advanced in the world and are used by many of the industry's top players, including TSMC, Samsung, and Intel. In fact, ASML's technological innovations have been key drivers in the industry's ability to continue to meet the demands of Moore's Law, which predicts the number of transistors on a microchip will double about every 2 years, resulting in exponential growth in computing power. More on this concept later in the video. This company basically has a monopoly on the machines needed to make chips, while all the other companies compete with each other in the actual manufacturing of the chips. This is a great position to be in, to be honest. On the other hand, we have Intel, which is one of the oldest and largest semiconductor manufacturers in the world, and is known for producing microprocessors and other computer-related components. It has many strengths, such as leading market position. Intel is one of the world's largest semiconductor manufacturers by revenue, and has a dominant market position in the microprocessor industry. Its brand and reputation are very strong, and it has a large base of loyal customers. Despite these strengths, Intel has a lot of weaknesses too, such as manufacturing challenges. Intel has faced manufacturing challenges in the recent years, leading to production delays and loss of market share to competitors such as TSMC. The company has acknowledged these challenges and is investing in manufacturing capabilities to address them. Samsung is also a leading producer of memory chips, including dynamic random access memory (DRAM) and NAND flash memory. Among its strengths are the vertical integration of its operations, with a strong presence in both memory and logic chips. If we have to spot some weaknesses, are the dependence on the mobile phone market for a large portion of its revenues. Now, taking a quick look at TSMC, which is the world's largest dedicated independent semiconductor foundry and is responsible for manufacturing a significant portion of the world's microchips. They have a huge dominant position in the foundry market with a market share of over 50%. Among its weaknesses are the dependence on a small number of key customers, particularly Apple, for a significant portion of its revenues. And more recently, we could argue that its geopolitical situation is not the best. Other notable players in the industry include Qualcomm, Broadcom, and Nvidia, all of which specialize in different areas of the semiconductor industry. Some of these companies specialize only in gaming, for example, or in the case of Amkor, which is one of the companies we'll take a deeper dive in this semiconductor series, they specialize only on advanced packaging of the chips because the chips have become so technological that the packaging also has to be very technological, and that can create huge margins and wide moats. Analyzing and understanding the industry trends and challenges such as moral law, globalization, and intellectual property disputes are essential for understanding the chips industry. The semiconductor industry is known for being highly cyclical, which means that its growth and revenue are subject to fluctuations based on the state of the global economy and other factors. The demand for semiconductors is tied to the demand for consumer electronic devices like smartphones, computers, and gaming consoles, as well as the growth of emerging technologies such as the Internet of Things and autonomous vehicles. During times of economic growth, there tends to be higher demand for electronic devices, which drives up the demand for semiconductors. This leads to increased investment in the industry as companies ramp up production and build new fabrication facilities to meet demand. However, when the global economy experiences a downturn, the demand for electronic devices tends to decrease, which can result in a slowdown in the industry of the semiconductors. This can lead to oversupply since the manufacturers of semiconductors cannot scale down their production as fast as the demand declines, resulting in a decline of prices, which can be challenging for companies in the industry. In addition, the industry is subject to a rapid technological change, which can lead to a shorter product life cycles and the need for companies to constantly innovate and invest in new technologies. This can increase the capital intensity of the business and require significant investments in research and development (R&D). Overall, the cyclical nature of the semiconductor industry makes it important for companies to carefully manage their investments and inventories in order to be prepared for changes in demand and technology trends. Another critical concept is Moore's Law. Named after the Intel co-founder Gordon Moore, it refers to the observation that the number of transistors on a microchip doubles approximately every 2 years, while the cost per transistor is divided by 2. This trend has continued for several decades and has been a major driver of technological advancements in the semiconductor industry. However, in recent years, there has been a debate on whether this trend can continue as the physical limitations of the chip manufacturing have been approached. This may lead to a slowdown in the industry's growth or a shift in focus towards alternative technologies. Globalization has also had a significant impact on the semiconductor industry. Many of the world's leading chip makers are based in Asia, particularly in Taiwan, South Korea, and China. This has resulted in a concentration of manufacturing capabilities and a reliance on a small number of companies for the majority of chip production. This concentration has led to increased competition as well as concerns about geopolitical risk and supply chain disruptions. Intellectual property disputes have also been a major issue in the semiconductor industry. Companies invest heavily in research and development (R&D) to create new technologies, and the protection of intellectual property rights is crucial to their ability to profit from their innovations. However, disputes over patent infringements and other intellectual property issues can lead to costly legal battles and delays in the development and deployment of new technologies. Additionally, some countries have been accused of intellectual property thefts and violations, leading to further tension and conflicts in the industry. On this part 1 of our series of semiconductors, you learned about the semiconductor industry, its key players and trends and challenges. I highly recommend that you subscribe to stay tuned for the next videos in case you want to learn more about this industry, since we'll take a deeper dive into Amkor's business model, which is one of the largest advanced packaging businesses, and we'll also add some amazing insights and unique experience from experts on this industry. Thank you so much for watching the video, and I invite you guys to leave any comments or suggestions that you may have. I hope you are having a wonderful day, and we'll see each other next time.